And next, I present to you Team Safety Carriers. They will give a presentation on proposal for amendments to SOLAS for controlling fire occurring from electric vehicles loaded on ro-ro ships. Shall we take a look at the introduction video?
Currently, electric vehicle fires occurred on board are also increasing rapidly as the demand for electric vehicles increases.
However, IMO regulations for electric vehicle fire are not sufficient.
We will present proposal for amendments to relevant regulations for controlling fire occurring from electric vehicles shipped on ro-ro ships. Let's carry safety together with Team Safety Carrier.
Good day, Chair, Your Excellencies, distinguished delegates, and ladies and gentlemen. We are Team Safety Carrier. This Team Safety Carrier would like to express our deepest gratitude for this valuable opportunity to present proposal for amendment to SOLAS for controlling fire occurring from electric vehicle shipped on ro-ro ships. We would present our proposal as follows. Background. Nowadays, regarding the worldwide concern about climate change, the interest in electric vehicle EVs has been growing due to its environmental friendly attributes. The chart on the left presents a projection anticipating growth of the global EV market for a decade, revealing an upward trend. Accordingly, the volume of EVs through international shipping is expected to boost proportionally. On the other hand, the chart on the right offers a forecast and comparative analysis of the number of EVs and its fire accidents in Australia. As recognized by most people, fire accidents in EVs usually have a notable substantial impact in terms of loss and aftermath. To begin with, I would like to share two recent fire cases in a ro-ro ships caused by an EV. In February last year, motor facility A's carrying more than 4,000 vehicles caught fire and unfortunately sank. Financial losses were expected to exceed $155 million US. In another case, in July this year, a fire broke out in the car deck of motor vessel Fremantle Highway, which was navigating near the Netherlands. According to the Netherlands Coast Guard, the ship was loaded with more than 2,800 vehicles, including 25 EVs. The sailor who witnessed the fire first testified that the fire had originated from EVs. As a result of tragedy, a crew life was lost and financial losses were expected to exceed $300 million US. Problem analysis. EV fires are mainly caused due to poor battery manufacturing, overcharging, impact, and high temperature. As we are aware, the vessel is easily exposed to impact and damage by high temperature in ro-ro ships. Regarding this, additional measures are required to prevent or to control fire on ro-ro ships loaded with EVs. The biggest concern about EV fire is the phenomenon known as thermal runaway. This phenomenon occurs when a single battery ignites by shock or high temperature as a domino effect. It spreads to nearby batteries, generating enormous amounts of flammable gas as well as oxygen. Without intervention to this feedback loop, spread of fire and explosion will continue. And finally, it would lead to a devastating accident. In addition, the flame from an EV battery tend to spread horizontally, and the rate of propagation is significantly faster than internal combustion engine vehicle as seen from the picture. According to the research by National Fire Research Institute of the Republic of Korea, from the point EV fire initiates, it takes only 1 minute and 50 seconds to spread fire to second car and 2 minutes to the third car. The maritime industry has been aware and concerned about this imminent and vital issue. In fact, Hyundai Glovis, a global shipping company in Korea, has suggested countermeasures to extinguish fire from EV on Ro-Ro ships with asphyxiation fire cover and potable water spray, and develop it as an internal regulation. However, according to the research of NFRI of Republic of Korea, in spite of the lower of fire cover, oxygen is generated as the lithium battery decomposes in high temperature, thus leading the situation to failure of air tightening. In addition, the potable water spray system was proven to be effective for the initial stage only. Regarding EV fire's attribute, it is difficult for crews to access or approach the fire breakout point due to the spread of heat and smoke, and also the loaded condition of the cars. In other words, asphyxiation fire cover and potable water spray are insufficient to extinguish fire from EV on Ro-Ro ships. EV battery fires are classified as metal fire class D. However, the class fire extinguishers are not effective on EVs because these fire extinguishers work by cutting and fire source, but the EV battery is composed of lithium ion and metal oxides, not lithium metal. Additionally, the battery is sealed and covered in the bottom, so the inner parts cannot be extinguished by itself.
To supplement means on this issue, this team would like to propose two measures. First, installation of partition and designation of EV zone. And second, undercooling water fire extinguishing system for EV. In this page, this team will explain a comparative analysis of two methodologies for extinguishing fire in EVs. One is the asphyxiation fire cover approach, and the other is the application of water to the batteries. First, in the asphyxiation fire cover method, it was observed that when a thermal runaway occurred, the temperature peaked at more than 850 Celsius degrees. It means there is a remarkable limitation in effectiveness with the asphyxiation fire cover. However, as the water cooling started, the battery temperature decreased significantly. Moreover, number 3 to 6 batteries did not reach thermal runaway since the temperature were maintained consistently low. Consequently, for controlling EV fires, it is clear that the most fundamental and effective strategy is to utilize water for impeding the transfer of heat. Move on to next page. It is about installation of portable partition and designation of EV zone. Considering its property, designating EV zone on Ro-Ro ship could contribute to control fire occurring from EV. Furthermore, for the safety of life, partition should be installed around each EV as soon as it is loaded. It could be more effective with a system that is combined of partition around individual EV and water spray from deck floor to EV's underbody, so that it can function as a water tank, allowing it to reduce temperature. The primary approach to extinguishing an EV battery fire involves cooling to prevent heat transfer and thermal runaway. External water supply systems are ineffective due to battery arrangement, but direct water application and submersion in a tank are highly effective. Therefore, this team proposed an underwater cooling fire extinguishing system with a partition around EV on Ro-Ro ships, considering battery packs typically locate beneath vehicle.
And it is our conclusion. Regulations regarding fires occurring from EVs on RoRo ships should be developed. This delegation would like to propose to include proposal of SOLAS Chapter 2 Part G and relevant regulations for control EV fires. As an output in the biennial agenda of Maritime Safety Committee with the next 2 sessions to complete. The draft amendment of the SOLAS Convention is as follows. Firstly, SOLAS Chapter 2 Regulation 19, Dangerous Goods should be amended. General requirements for RoRo ships should classify EV separately, and the water spray system under the special requirements should include provisions for underwater cooling systems. And secondly, Regulation 20 about fixed fire extinguishing systems of RoRo ship, but it is not sufficient for EVs. So it can impede safe navigation. Therefore, it is required to cover fixed underwater cooling fire extinguishing system, including partitions of EVs. Thirdly, International Maritime Dangerous Goods IMDG Code Part 7 provisions concerning transport operation. Classed as dangerous goods, lithium batteries are subject to extensive international legislation. For shipping, the IMDG code is the primary document within which electric vehicles with their batteries inside are classed as UN 3481 or UN 3171. The IMDG code undergoes a 2-year amendment cycle, which has been characterized by ever-tightening changes and lengthy exclusion criteria. We suggest segregation of cargo transport like full container ship. For container ship, there is another bay for DG. RoRo ships which loaded EVs should separate spaces for extinguishing and monitoring EVs sufficiently. Lastly, we could discuss which strategic directions our proposal falls under as mentioned in the document. We submitted our agenda falls under SD2 and SD6. We could improve the implementation of output by guidance, and we could integrate new and advancing technologies by proposing amendments to control EV fires. This delegation is of the view that we should develop countermeasures against identified risks such as fire occurring from EVs for enhancing maritime safety and protection of marine environment. For more effective and efficient control of fire from EVs on RoRo ships, this delegation proposes amendment to SOLAS and relevant regulations and requests the committee to consider this proposal. Team Safety Carrier would like to express our sincere gratitude for sharing your valuable time with us. And thank you, Chair.
Thank you, Team Safety Carrier, for the nice presentation. And there will be a Q&A session about this presentation. Will any of the judges have questions? Okay, Mr. Seo, please.
Thank you, Safety Carrier. I fully agree with you. The best solution is water cooling, and in line with the amendment of SOLAS Chapter 2 to Regulation 20 could be very realistic. In your slide, page 14.
14.
Yes. Fuel car and/or truck carriers have each fire compartment in cargo spaces. One compartment could have 3 movable car decks, which have holes on the bottom of the cargo decks. In the case of spraying water upwards or submerging electronic vehicles in fire, could detrimental to the ship's stability and strength. In particular, in the case of above freeboard deck, which area do you, in your mind, to designate this EV electronic vehicles in the car decks?
Thank you for your judge for your thoughtful question. And as you question to us, we think the EV zone should be in the bottom of the RoRo ship because of ballasting problem and GM. So maybe maybe if we are the constructor of the shipping, maybe our team would like to suggest the bottom of the Loro ships. Thank you.
Okay, thank you very much.
Okay, thank you. And are there any
I have very
Okay.
quick other questions in page 7.
page 7?
Do you have any clear grounds which rotor ships are easily exposed to impact and high temperature in terms of the causes of electric vehicle fire? You make boxes to the last two, impact and the damage of high temperature. Do you have any clear ground to identify as these two could be the major causes of electric vehicle fire?
Yes, but in short, the electric vehicle fires occur a lot by overcharging. But in ships, there is not a charge installation in Loro ships. So our team research about the cause of the reason why it is exposed very frequently to in Loro ships is by impact like rolling, pitching, and also in Africa is very high temperature. It makes the electronic battery temperature very high. Yes, thank you.
Thank you. And are there any questions from judges? Okay, let's move to on the floor. Okay, circuit breakers, please.
Thank you for your ideas, safety carriers. But however, from what I have researched, the reason why controlling EV fire is so hard is yes, because of their distinct features, but also because of their special constraint of the PCTC itself. So do you have any further ideas to solve out these problems?
Thank you for circuit breakers for a software question. But can you say again? But I can hear your voice well.
So from what I have researched, the reason why controlling EV fire is so hard is yes, because of their distinct features, but also because of their special constraint of the PCTC itself. So do you have any further ideas or milestones or guidelines to solve out these problems?
Please can you give me time for a question? Okay, thank you for your patience. And I never heard about the construction issue by the Loro ships. Can you give me the example of the what you mean that construction problem is happened?
So the special constraint from what I meant was the gap between the cars, especially EVs. There's actually very small gap between those cars, so I don't think there's any space to put your dampers or any kind of
Yeah, I understand your question. So yeah, as you know, the gap of the car is very small, right? So our team think about that and consider about the problem. So is the portable tank or the partition is only used for when the car is in the initial fire stage only, because the electric vehicles are spread very fast than combustion engine vehicle, right? So the gap between the car is the problem with the gap. It is only considered by when a car is fired. Like if the fire is so big, the Siemens cannot go into the deck. Thank you.
Okay. Yes, Miss Captain Kwak. Yeah,
Yeah.
please.
Yeah, I heard your explanation, and I think the individual electric vehicle partition is impossible, I think, because there is the lateral spacing between car is only 10 centimeter, and the longitudinal spacing is only more or less 1 meter. So the individual partition itself is impossible in current situation. So I think that is not practical at the moment.
Okay, thanks for your comment. What do you think about that?
Thank you, Judge, for your thoughtful question. And the partition doesn't pose any issue for passage because the partition we refer is a movable partition in case of an initial fire.
Yeah. Anyway, when car is full loaded on a car carrier, the approach itself is very difficult. You have to consider that point.
Thank you for your feedback. I really respect your suggestion, but our team emphasized about the portable partition. It's not a fixed partition. Thank you.
Okay, thank you so much. And are there any questions from the floor? Okay, Civilizer, please.
Thank you for your presentations, and I have one question. As I know, the PCTC are already designed that they can block each sections and they can capable of CO2 extinguish each sections. Then does water cooling is, I think the water cooling does not necessary.
Thank you for your question. Through the past Loro ships fire incidents, the limitation of CO2 have been evident, as highlighted in the Firefighting Institute finding. Despite the external cooling, electric car batteries may retain internal heat, potentially leading to a thermal runaway. Considering that battery combustion generates oxygen and a flammable gas, the suffocating effect of CO2 has its limitation. Therefore, as indication by the Firefighting Institute research, undercooling water fire extinguishing system proved to be the most effective method. And shortly, the battery pack is generated when the oxygen by the decomposes itself. So CO2 maybe cannot helpful. Also in the research of the fire accident in ships, the CO2 is not working very well because it have vent problem, and the all crew have run out from the cut deck, and the all vent have to be closed. So it is have some realistic problem in the ships, I think. Thank you.
Thank you. And it's time to wrap things up. So yeah, thank you very much, Team Safety Carrier, and everyone please give them a big round of applause.